Mhm. Life, yeah. Yeah, it was cool how they made you think that it was the Switch. Yep. Yeah. Yeah. I would like to see a sequel. I don't think so. I don't think there would be, like, but it would be cool. You never know. Yeah. Yeah. Yep. Yep.
try to remember you, but you're like a dying tree, time tall. Like you know what I mean. Even when it's dark out, I can see the light in you. Even when it's dark out, I can see the light in you.
Now right here, right below this line, 819 and 820, I'm kind of wondering if it pauses the game. Because if it doesn't, I see this while click deletes one carring is false. That means like theoretically this whole section would run again. And if this whole section ran again like a while it does, that means we would have this section being run again. And we don't want that to happen twice. We only want that to happen one time. So let's look up that function real quick. Let's see what it says. So it says while, okay, so it itself contains a while loop. So that's good. Okay, so that should avoid this issue that I was concerned about. Yeah. I just wanted to make sure. This is where we get the bug. It's saying current player preschool play cards pen, current player dot hand pop, current player dot hand index of the current card. Okay. And you know, obviously the card should be in the hand. So where we get them from to be in the clickable. So if they were in the hand, they're in the clickable, and then if we click them, that means they successfully got from the hand to the clickable, and then that means they got successfully from the clickable to the clicked. So that's, to me, sounds like it's working up to this point. Then, for whatever reason, oh, you know what? I think I already asked this question before because I've already encountered this bug. Matter of fact, this is not a data transfer modification bug. This is a bug. This bug existed from long ago, from generations past. This bug is old. See, watch, continue debugging label playthroughs. This is from back in February. We have the red 3 face down bug, not that one. Well, yeah, that's actually, we're done. We got like this non-issue now. Order of dirt check calls during debugging when noticing the received dirt check sequences are now important since trouble debating sequences have been completed, but also whenever card movement is called, aka anytime a card is and after reviewing consider the order of these dirt check calls to ensure that the ordering is not causing visual bugs. This has been the case. Yeah, I think we fixed that. Like we were doing game and then player and stuff, but currently, I think we're like, I don't think that's an issue anymore since we do golf at timestamps. It's always gonna be in the right order, I think. Let me think about that for a second. Because, well, so let's say that we make a change to the player, and then we make a change to the game. Would the first change be detected first, is the question. Would the player change be detected first? Because we added in the timestamp system. But the timestamp system is, now that I'm thinking about it, technically I don't think it's perfect, is it? Because in our instance that our proposed instance here, if we were to change the player and then change the game, but let's say, okay, so we're on server side. We change the player, we change the game. The question then becomes, how do we know that the first change okay, yeah, right, okay, here we go, yeah, so, okay, wait, I think we are good in that regard, because if the player was changed first and the game was changed second, even if we were, so remember, it's multi-threaded, so dir check is always checking for changed data. So when we, on its own thread, it's got two threads that are always checking, saying, is something changed yet? Is something changed yet? Is something changed yet? Just over and over, every like microsecond. And it checks in a certain order. It checks first for the player, then for the game, then for the location, then for the deck, etc., etc. So if we changed player first, then we changed game. If whenever we changed the player data, it was actually had just run this player dirt check like a split second, you know, before that change was made, well, it wouldn't get sent because it hadn't been changed yet. But let's say that the game data that got changed immediately after happened right before this dirt check ran. That means game data would get sent first, player data would get sent second, and we would have out of sync send. We would have data that needed to be applied after being received first. But since we added the timestamp system, it's not going to automatically apply that game data. Oh, no, it's not perfect because it actually does go off of the dirt check and not the actual time that the data is changed. Oh man, that cuts like a knife. Oh no. Okay. Well. Okay, so here's the deal with that. That means I made a critical mistake way back in thinking about how to do this properly. I was on the right track though, but now I see that, and I should have caught this way early when I was doing the data transfer management. I should have saw this like a while back, but I didn't. Okay, so the deal is that actually in the instance I just proposed, the game data actually would get applied first. So how do we fix that? Well, the issue is, first we have to identify the problem, then we can figure out a solution. So the problem is that even though we're getting the time, and that's a good thing, we're getting the time too late. This time value is not it's not early enough. We need the time value to be exactly we need, and I think I already know the solution, but that's what I thought last time when I fucked up and I did this and it was wrong. So I'm gonna think about it even longer, because if you just think about it even longer and it takes you an extra 10 minutes or 20 minutes, even 30 minutes, even an hour, but you're doing it right, you're gonna save yourself 2 hours in the future. Like I just did that, and I lost time because I didn't think it all the way through enough. So here's our options. What we can do is, and this is actually something that Gemini recommended, I think, was, and I'm gonna put this here, so let's actually just I am pretty sure this is a playthrough bug. Is an old playthrough bug that already existed before DTM. Okay. Okay, well this is ass. Man, I'm pissed now. This sucks. Anyway, okay, so it's really not that big of a deal. I mean, the bigger deal is that I didn't notice it in the first place. That's the bigger problem. Anyway, there's always room for improvement, right? So, okay. So we're gonna put this note in. Alright, so we're gonna put this right here. We're gonna say, well, actually this is not a subset of DTM. This is really like a restructuring of the data transfer modification altogether. Fuck. Noticed when reviewing DTM logic that it is still imperfect at a basic level. The pre-send timestamp is an idea going in the right direction of data sorting. The timestamp given at time of dir check still allows for data to be sent out of order. If player data is changed first, but then game data second, but dir check game gets run first. Player data is changed first, but then game data second. But dir check game gets run first. The later change will have an earlier timestamp, meaning it will be applied first. Yeah, and we don't want that. That's bad. Okay, so possible solutions. One would be, and here's my solution that popped in my head off the bat was, so since we run dir check in terms of player game loc deck, then we could have a class attribute attribute that acted as a switch or like an ID or something of that nature. ID. Something of that nature that basically would, well, actually that would be maybe at an even higher level, because we would want to see if any, like, okay, so if we changed a player first but then the game second, let's say we change the player's name, at the moment that we change the player's name, we would have like some way to, for like the class object to say, hey, something has changed, like not dircheck, and then basically whenever that data was changed, we would want to like we would just we could do the timestamp then, or it could just be like an integer, and the integer gets incremented by 1 every single time a change is made. So like let's say for instance the integer is like 64 at the time we change that name data. So then it would like assign, we'll just call this like the change ID. Its change ID would be 65 or 64, whatever. And then completely separate of the dir check being run, whenever the game data was changed, that would have a value of 65, the change ID of 65, acted as a change ID. Note that a particular data change preceded another. But here's the thing with that. Actually, this was something that I was thinking in the past that I would have to do, and then I was like, no, I won't have to do that. That's too much work. We're gonna have to, like, because here's the deal with that. If we implement that, that means, like, okay, so first of all, we'll put this how or we'll say hurdles. We'll just call this hurdles to implementation. Since this would have to be either a class attribute or something like that. What else would it be other than a class attribute? Like, I mean, how, I don't know if we could check it on a higher level than that. Since this would have to be a class attribute or something of that nature, we would have to have a mechanism that always set this attribute whenever any class instance data is changed, or not even like, not even oh man, I'm just like, oh no, this is making me feel like, oh no, this is gonna be a lot of work. Fuck. Yeah, because this, whenever we change anything, like if we change the name, that means, like, how would we actually know? Let's see, TLDR. How will the game actually know the data has been changed? We would, it seems like we would have to, well, one thing we could do would, we could check the attributes. We could check all of the attributes of a given object, but like, again, that's basically what dir check is. Oh. This is basically what dir check is. Okay, but okay, all right. I think I'm starting to. I might have an idea here. Hold up. What about this? What about? What if instead of that, we would pre-sort we would pre-sort the yeah, but how would we pre-sort the dir check? Like, how do we know? How do we know? Like, how would we know that the player data was changed first? You see what I'm saying? How would we know that? Let's just think. Let me think about this. So, okay, there is another way to do this. And okay, so basically we could add another layer of checks. I mean, like, we could add another delay. after we change the data. So like basically I'm thinking like data clusters. Like, okay, so I'm thinking like pauses before dir check resend. This is just very like brainstormy thought process. So I'm just thinking like so we changed player first, we changed game second. The current way it's set up is dir check waits on no man. So dir check is out of order. It has no way to tell which thing should be sent first. But okay, that still wouldn't fix the problem. I think like no matter what solution I propose, that solution has to include having the timestamp of the exact moment that the data was changed. I don't think there's any way around that. So just adding this timestamp thing does help, but again, it's not precise enough. It has to be exactly an exact reflection of when the data was changed. Now let me just think. Okay, let's just say I'll put here. I'll put no matter what. Actually, let's put this right here. No matter what, we would no matter what solution we choose, no matter what solution we choose, it must contain the precise timestamp of exactly when any and every data point was altered for it to be identified properly in terms of what should precede other data. And I'll just put this way at the top. No matter what solution we choose, it must contain the precise timestamp. It must contain the implementation. Fuck. I didn't want to do this. Damn it. Must contain the implementation of the precise timestamp of exactly when any and every data point was altered for it to be identified properly in terms of which precede other data. Okay, so this still doesn't solve the issue. If the timestamps are not precisely aligned with the time of data alteration, we won't know which change should be sent applied first. Damn, bro. What a bummer. Okay. At least I know. At least I know now what what I have to do, and there's really no way around it. Yeah, well, you can't push the goalpost back any further than this. So I'm like, on the bright side, at least when I implement this, there is no earlier point. You know what I'm saying? Like, this is as far back as you can go. We're going back to the dawn of time. You can't go back any further than that. So, well, hopefully this will be the last data transfer management modification we have to make, as far as like time stamping and all that. Okay. Get a little bit more coffee. I'm feeling sleepy. So ask ChatGPT, why am I so dumb? I highly doubt you're dumb. Everyone has strengths and areas where they can improve. Sometimes we might feel like we're not as smart as we want to be because we're comparing ourselves to others, or because we're facing challenges that might make things difficult. But it's important to remember that intelligence is multifaceted and there are many ways to excel. What's important is recognizing your strengths, working on areas you want to improve, and being kind to yourself along the way. What's been on your mind lately that's making you feel this way? Fucked up my data transfer management modification and didn't use the best logic, so I used the wrong timestamps. Mistakes happen, especially when working on complex tasks like data transfer modification. The wrong timestamps? Is there a way to correct the mistake or mitigate its effect? Yes, I can. Yes, that is correct. I have to backtrack and redo it. Beautiful. Damn. Damn. I was all excited too. I was like, oh, I fixed it. Yay, it works. And then I'm like, today. That was yesterday. And then today. Damn. I mean, I was on the right track, but if I would have just spent a little bit more time thinking it through, I would have realized probably like in 15 more minutes out of just like not coding and just being like, wait a second, think about this a little bit more. Realized, wait a second, that actually is not gonna work. You know, I actually did like think about that, but for some reason I just didn't, like, I wasn't clear-headed enough, I guess. I thought it was gonna work. I don't know why. I don't know how I missed that, but I did. Well, it looks like now I just want to think about this for a second. Does this mean, well, actually, okay, let me think about this. You know what? This might not be a total L, because we're still gonna need to sort the data by timestamp, right? Isn't that true? Like, we're still gonna use the timestamp system. So those few hundred lines of code that we added, we're still gonna use that. So that is not like, that was not a waste of time. So that makes me feel a lot better. So in reality, how much of it is an L? Like, how much of the DTM that we did is an L? Well, let's just be honest. Not really much, actually. The only thing is, basically, so we're using everything that we implemented already. It's just now I'm realizing I still have to implement more. Yeah. So like this little line of assigning, putting the current time equals time, that is the only like thing we're gonna end up getting rid of. We're just gonna have to figure out a way. So here's where we're at right now. Let's see, but so the third solution would be this would be well, actually, this is actually the same thing as number one. Since we run dirt check in terms of player game look deck, then we would have a class attribute that acted as a switch or an ID or something of that nature that acted as a change ID to denote that a particular data change preceded another. Or timestamp ID timestamp switch ID timestamp acts as a change ID to denote a data change preceded another. So we'll just shorten this to be a class instance attribute that acts as a switch ID. Furthest implementation would be, since you have to be either a class attribute or something of that nature, you'd have to have a mechanism that always hits attribute or any change. And the TLDR for that is, how will the game actually know that it's been changed? And then one of the options was we could check all of the attributes of a given object, and then that's like basically what dirt check is. So that seems like not the best idea. So I think probably a better idea would be for hold up. Yeah, so like this is actually like right here in the same line of reasoning. We would check all of the attributes and compare them against their previous attributes, and then we would want to check to see is anything different than it was. But still, that would have to be ordered. That would still have to be ordered. You see what I'm saying? Like, again, how, even if we did that, when we were, like, the only way that that would work would be if we ran that check, and this, we'll just call it the check, and if that check checked every single thing, oh, I see where I'm going with this, dude. This is basically a modification of the dir check to where instead of calling dir check 4 times, we would just call dir check once, so that, like, we would be, the dir check when it ran would check everything. How does that work exactly? Like, would that solve the issue? If whenever we ran dir check, instead of only checking for the player, and it checked everything, wouldn't that mean, like, man, this is really a complicated thing to think about, because, like, when you're changing data throughout the progression of the game, you are changing various different data points, and those data points are divvied up between like 4 different objects or files that basically come together as one client or whatever.
For we don't truly die until death.
But the question of applying all of that data in the correct order is important. Like, we can't, I don't think so. Here's where I'm at right now. If we were to just make dir check all encompassing and check, we had one dir check, one send dir check call, let's actually use one pre-send dir check which checked all player game locations deck, all aspects of the client data, instead of 4 pre-send which each check one aspect of the client app. let's say issues with idea. So what's the issue with that idea?
It's funny, this game of life. Each human believing in a sense that they are immortal, safe from death, untouchable. I suppose it's true in a sense. While we are alive, we are as such, immortal beings.
Okay, so not sure if this is an issue with the idea, but I'm thinking like
Yet, might we be considered
if we were
fools
to
for undermining?
do that, would it actually fix the problem that we have? So if we only had one dirt check, and we just, instead of issues,
For we
I'll
don't
just
truly
put
die until we die.
would this actually solve the problem? Application. And would it, like, because it raises the question of, let's say we just don't do a timestamp for every single data change. What I'm really trying to avoid doing. Would this act in a similar manner? And that relies upon, I think, whether or not, if we sent larger data clusters,
I suppose it's true in a sense. While we are alive, we are as such, immortal beings.
would the application of that
Immortal
data
meaning never dying. For we don't truly die.
be like would it be ordered by nature of the fact that it's all being changed? You know what I mean? Like if on the server side we're saying we're changing the player, we're changing the game, we're changing the player's name, we're changing the game progression text, we're changing the deck face up discard, all that at once. Whenever that gets caught in that singular dir check and gets sent over, does that mean that the client side, when it applies that data, is it gonna be ordered properly? And if it's not ordered properly, is it going to run correctly? You know, like is it? I don't think it would. I just don't believe. I don't think it would. I don't think it would matter. I don't think if we had one dir check instead of 4, that would fix it. Now, from a purely like project optimization perspective, I think it could be beneficial. You know, like less code is better. I think it makes sense for us to have one dir check instead of 4 if we could, because that would reduce lines, it would improve readability, it would reduce chances for bugs, it would reduce difficulty of debugging, or at least maybe it would. Maybe that's not actually true, but that, yeah, I don't think it would fix our problem. I don't think it would actually fix the issue because the client still wouldn't know which of that data to apply first. And then this ultimately leads back to the issue of requiring the exact precise moment every single bit of data is changed. Which is not what I wanted to hear. Damn. I'm trying to reason my way around this. I'm like, there's gotta be another way. There's always another way. Okay, so we're gonna put in non-pressing issues, something to do much later in the future. We'll add this as decided, or not decided, while debugging DTM logic issues associated with imprecise time stamping for data application sorting, realized that I couldn't give a good reason as to why we use 4x pre-send sender check instead of just one. Consider implementing one large, all-encompassing third check instead of four. And we'll call this 1x dir 1x dir check instead of 4x. Alright. Yeah, but at this point we're basically like, I mean, well, with the system we're making, we could just go ahead and code like fucking World of Warcraft or something. Like, we didn't want to go this far with the precision. I just didn't want to do all that. At this point, this is an entire game engine. Well, need some water. Feeling dehydrated with coffee. So overall, not a total loss, but definitely more work than what I thought. Um, you know. Okay. Yeah. So we're gonna end up going with. Let's see. And then quite certain we have to identify every single data change and order it by whatever identifier that ends up being. So would this be a timestamp, or would it be a incremented change ID? So that's where we're at right now. But not a solution. Determined as a non-solution. And then number 3 still is also, that also is determined to be a non-solution. Okay, and then we're gonna say that note probably the best proposed idea or solution so far. Okay. So we're gonna minimize 2 and 3. Minimize that. Sorry. So I think we're gonna go for like 12 more minutes to get to 5, and I'm gonna call it quits for the day. So I think ultimately what's gonna end up happening is we're gonna be replacing, like, we're gonna be replacing this current time with I still have to think through for the specifics. So we're gonna have to have a timestamp for, well, not necessarily a timestamp. It could be an incremented change ID. And that could be, okay, so there, I'm taking a step with this. We could say this incremented change ID, we could say could be a client instance attribute. So let's think about that. If we had I don't know about that though. So I'm thinking of this as basically like an integer, and it's a class attribute, and every time you change anything on the client, you assign this change ID so if we were to do that, it's like I'm just trying to think about how we would actually be able to do that. I think that would work better if we had a single dir check as we like had proposed, and I want to just put that as a note. Seems like this would require a single A1X pre-send dir check as proposed. Alright, as proposed previously. Because then if we only had one dir check, and at the time of that dir check, well, no, that's still not gonna do it, is it? Because that has nothing to do with, it has nothing to do with whenever the individual data itself has changed. But okay, now actually, yeah, if we made it to where instead of every time we changed any particular class attribute or whatever, if we made every single change have an associated change ID, that we would basically have to have like a dictionary that for that change ID there would be an associated value, and that would be like whatever the change was. Because it's not just enough to say that it's not just enough to say change, like the player data change happened before the game data change, because even within the player data change, there might be a few different attributes that have been changed, and the client still would not know which of those things to apply first. And we have already established that we can't rely on the order of sending you know, unless that is another possible solution to where this is like in a completely different direction, would be to figure out a way to ensure that the data is sent in the right order. But like, you know, that's what we're doing. I was just trying to think out of the box here. I was also thinking in terms of like using thread locking, or like using what do they call it? Synchronization. But I think really what we would be looking for would be like a lock. But I still don't think that that would fix the ultimate issue. The ultimate issue is that on a very a minuscule level, the data needs to have an order, so that the exact same order in which events happen on the server, the events happen on the client. So like, what if, and this is like a complete restructuring of our entire thing, would be, what if we used a mirror of the of like the progression file on the client side. And I'm just gonna say no to that, because that is a complete restructuring of our game. Not to mention, I don't even know how you would do that. But yeah, that would solve, or at least you would think it would solve the out of sync thing, because instead of having to make it nice and orderly, it would already be in order, because the events would happen on the client side exactly as they happen on the server side. But how would you get the game to progress? Because you can really only progress the game in one place. That sounds to me like maybe something I probably could have done, but that is so far back, like that would be too much. And I think we could find a much easier solution. So I think first of all, it looks like no matter what we do, we have to identify, add an identifier for every data change. And as long as we had that, the system we already implemented would handle the rest, because we already are going to sort it based on the timestamp. The issue is just that we don't have an accurate enough timestamp. So I think the idea of the incremented change ID is not as good as the timestamp. I think the timestamp is a better idea. So yeah, we're gonna just, I think we're gonna scrap the incremented change ID thing. Let's see, after further thought, it seems more logical to use a timestamp instead. But I'm gonna put, don't discount this idea completely now. It very well may be So, and that's something that I want to make sure I do. Like at a moment like this, where I'm like, I don't want to spend so much time thinking about this anymore. I'm pretty sure timestamp would be better. I don't want to just throw away the possibility of using this. I can start going down the direction of the timestamp thing, but I want to come back to this before I implement the timestamp and say, so now we've brainstormed the timestamp. Let me go back and brainstorm the change ID thing again, because you never know. I might realize something in the future that will help me be like, wait a second, actually, we could do this with the incremented change ID and it would be better. But for now, we would have to. We're gonna go with the timestamp direction, and that would mean we would have to either to implement this, we would have to either add the timestamp as derivatively assigned via calculated properties, or via direct subsequent assignment in places where the data is directly changed, like progression.py. Where else? Like you know, I think mostly that happens in progression.py, but it also happens elsewhere. And we actually already have some timestamp stuff implemented, which we weren't really using, or well, we do use it actually, but we use it for a different purpose. So some of this is actually already done. Some of these attributes would already be handled. So yeah, I think that's the direction we're gonna go in, but I'm gonna call it quits, and I'm gonna be thinking over the next day until tomorrow's coding session, if I do have one. I'm gonna be thinking about this incremented change ID thing, because I don't want to just run with the idea, because that's what led me to. It didn't really cause me so much trouble as I thought it did when I got bummed out about it, but I shouldn't have been so confident in it, because I just didn't think it through a little bit more. If I would have thought it through a little bit more, I would have realized, hey, yeah, this is a good direction, but ultimately it's not actually going to completely fix the problem. We still have more work to do. But instead I was like, oh no, this is it. This is going to completely fix it. So I don't want to do that with the same thing with, the idea of, hey, should we use timestamp? Should we use increment change ID? So anyway, we're gonna do that next. This is gonna be where we stop. 1, 2, 3, 4, 5, 6. Stopped here. 2, 3, 4, 5, 6. Now, so stop here. Begin implementing this code. Well, let me put after more brainstorming and fleshing out the final process, because we have to make sure that make sure this these timestamps will have a way to actually be used at the endpoint and are a 100% solution before implementation. No more of the code first, ask questions later. Let's do all of the question asking and answering before we write a single line of code. I know it's very boring and it doesn't feel productive when you sit there for an hour and you don't code, because it feels nice when you're actually writing code, but you might just be wasting your time. Alright, so let's go ahead and update our devlog. We stopped at 5. That was an hour and 45, which is 1.75 hours. And I'm gonna put 3 to 5. We discovered that our DTM is not actually finished. We need a more precise timestamping system. Brainstormed and outlined various problems and solutions. Ultimately decided on 2 possible solutions and two possibly viable solutions and 1 almost certainly viable solution. Decided that we should try to use direct data change level timestamping for each pattern. Alright, and that's it. That's all we did. So now we're going to, we update our things to do. We did everything that we could here. Yeah, we updated everything. So now we're gonna go back to root directory. We're gonna check our branch. We're on secondary. That's where we want to be. We're gonna git add everything, and the warning there is inconsequential. So we can say git commit m, and now commit node looks good. Then we're going to git push to connect secondary. Now we're going to make sure we had 6 files changed, 64 insertions, 24 deletions. We pushed to the remote and it looks like everything worked. Okay. And I already backed up the project, so today. See you next time.